Find out the value of k such that sin x to the power 6 plus cos x to the power of 6 plus k multiplied by sin x to the power of 4 plus cos x to the power of 4 is equal to a constant for all values of x. Assume that k is real. Let sin x be m and cos x be n, then our given equation becomes m to the power of 6 plus n to the power of 6 plus k multiplied by m to the power of 4 plus n to the power of 4 is equal to a constant. Let us call it equation 1. Now, m to the power of 6 plus n to the power of 6 is m squared raised to the power of 3 plus n squared raised to the power of 3. We know the formula x cube plus y cube is equal to x plus y whole multiplied by x square minus xy plus y square. Therefore, this becomes m square plus n square multiplied by m4 minus m square n square plus n to the power of 4. That is equal to m square plus n square whole multiplied by, again we can rewrite this as m square plus n square whole square minus 3m square n square. Since m is equal to sin x and n is equal to cos x, we have m square plus n square is equal to sin square x plus cos square x, and that is equal to 1. Therefore, m to the power of 6 plus n to the power of 6 is equal to m square plus n square whole multiplied by m square plus n square whole squared minus 3m square n square, and that is equal to 1 multiplied by 1 minus 3m square n square, and that is equal to 1 minus 3m square n square. Similarly, k multiplied by within parenthesis m4 plus n4 is equal to k, and m4 plus n4 can be written as m square plus n square whole square minus 2m square n square, and that is equal to k multiplied by 1 minus 2m square n square, because m square plus n square is equal to 1. Therefore, equation 1 becomes 1 minus 3m square n square plus k minus 2k m square n square is equal to a constant, or 1 plus k minus m square n square multiplied by within parenthesis 3 plus 2k, and that is equal to a constant. Let us call it equation 2. Now, since m is equal to sin x and n is equal to cos x, we get equation 2 as 1 plus k minus 3 plus 2k whole multiplied by sin square x multiplied by cos square x is equal to a constant. Let fx be 1 plus x minus 3 plus 2k whole multiplied by sin square x into cos square x is equal to constant. Let us call it equation 3. We realize that the only variable term in the above equation is this, or 3 plus 2k multiplied by sin square x into cos square x, because the other term 1 plus k is a constant since k is a constant. If this expression, that is this expression, is a particular constant for all values of x, then equation 3 will hold good for all values of x. Before going any further, please like, subscribe, share and hit the bell so you can be immediately notified for new uploads. It's completely free and only takes a few seconds, and you can always unsubscribe later if you want to. Also, if you know about any interesting problem that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. So let's examine sin square x multiplied by cos square x for different values of x. We know that sin 2x is equal to 2 sin x multiplied by cos x. Therefore, sin x multiplied by cos x is equal to half sin 2x, or sin square x multiplied by cos square x is equal to 1 by 4 sin square 2x. Therefore, when x is equal to 0, 1 by 4 sin square 2x is equal to 1 by 4 sin square 0 degree is 0, because sin 0 degree is 0. Similarly, when x is equal to pi by 4, we have 1 by 4 sin square 2x is equal to 1 by 4 sin square pi by 2, and that is equal to 1 by 4 because sin pi by 2 is 1. When x is equal to pi by 8, we get 1 by 4 sin square 2x is equal to 1 by 4 sin square pi by 4 is equal to 1 by 4 multiplied by 1 by square root of 2 whole squared, and that is equal to 1 by 8. Thus, sin square x multiplied by cos square x cannot be a particular constant for all values of x, because we have seen for 3 different values of x, the values of sin square x multiplied by cos square x are 3 different things, 3 different constants, not one particular constant. Therefore, the only situation for equation 3 to hold good is when the variable term vanishes for all values of x, and the variable term being 3 plus 2k multiplied by sin square x into cos square x, and that should vanish. That means that should become 0. Since sin square x multiplied by cos square x is not a particular constant for all values of x, we conclude that the term 3 plus 2k must become 0. That is, 3 plus 2k is 0, or k is equal to minus 3 by 2. That is the answer.